Hello! Let's talk about Archimedes' principle. This principle governs what happens when you submerge a can in water. To look at this, Archimedes wanted to think about the pressure on such a can. The pressure is governed by the depth, which Giancoli has decided to label as h, so we'll stick with that. As you can see, the depth at the top of the can, or perhaps the height, is higher than the height of the bottom of the can. This results in two different pressures, which in turn results in two different forces. This change in forces means that the can is going to move in some direction. We'll label this total force the buoyant force, and we'll find it by subtracting the second force from the first force. Here you notice h2 minus h1 is simply the total height of the can. Thus we change this to the area times the height of the can, which in turn you might notice is simply the volume of the can. Finally, we can notice that the volume of can times the density of the water is simply the mass of the water displaced by the can. This is the cornerstone of Archimedes' principle. Let's move on. We still don't know what happens next. Does this can go up? The buoyant force we just found is surely pointing upwards. Perhaps the can shoots out of the water. But we haven't accounted for what's inside the can. Is it full of air, water, steel? We don't know. Let's consider a couple examples. We know that there is a force of gravity acting on this can. So we simply take the mass of the can times gravity as usual. The total force then is our buoyant force minus our force of gravity. We can see quickly that whether or not this goes up or down depends on which is bigger, the mass of water displaced by the can or the mass of the can. If it's full of air, we can assume the mass of the can is basically zero, and the force will go up. If it's full of steel, the mass of the can is probably greater than the mass of water displaced by it. Thus the can will sink. Interestingly, we found that the buoyant force doesn't actually care about the mass of the can. It ignores it completely and only cares about the volume of the can. The mass of the can only affects the gravitational pull, which in turn decides where the can will go.